Yes, sir.
Yes, sir, we can hear you.
Okay, good, good. So our discussion will start with run length encoding. Okay, I'll explain with different references as well. Simply, run length encoding is a method through which you can compress your image, okay, your text in any way. For example, if you have an image and if you have a part of it in which a black color is being repeated, let's say this part is entire black. So how would it reduce the information within the image? What are the methods that can help it to do it? Well, the way is that, um, for example, if you have 10 black pixels, it will simply say 10 multiplied by black. Let me explain you with more examples. Okay, run length encoding. So run length encoding can be used to compress a number of different formats. Okay, images, you can have videos, you can have text. So if you have a repetition of something, for example, if you have A appearing multiple times, B appearing multiple times, C appearing multiple times, D multiple times. So the way we can reduce it is we'll write 0.5 multiplied by 97. Now what is 97? 97 is the ASCII code of A, okay, and 98 is the ASCII code of B, okay. So what are ASCII codes? ASCII codes basically are your decimal numbers given to every character that you have. All the 256 characters have an ASCII code, okay, instead of be representing through binary numbers. So you see, even if I have, let's say, 20 Bs, I'll simply write 20, 98. Basically, uh, it's 04 multiplied by 98. Actually, it's written like this at the back end. So we have over here is 299, 5, and 100. So D has an ASCII code of 100. So this is the way you will be able to limit the information. Instead of repeating a lot of characters at the back, you simply write the ASCII code of that character and you multiply by the number of times it's appearing. This is known as your run length encoding, right? Okay, am I recording this as well? No, you're right, I should be. Let me record it, it will be better. Oh, I'm recording it, good. So, you could also have run length encoding with images. For example, if you have this image, obviously the way this image, this is appearing is the pixels that you have for F, they are basically black, 0, and you do know black is 0 and white is 1. So wherever I have this black, it's F. The rest are 1. So in compressing the run-length encoding format, this would be um, 9 white. 9 white means 1, 2, 3, 4, 5, 6, 7, 8, 9 white, because I told you we go this way. And then we have is 9 white and 1, 2, 3, 4, 5, 6 Bs. 6 Bs, okay, and then 1, 2 white and 1 black. Are you seeing what I'm saying? I'm reading from this particular side, okay, then 7 white, okay, right. So this is the way it keeps on going on, right. I was reading, sorry, the other way. It was supposed to be this way, then this way, then this way. Then we have is 1 black, and then we have 7 white, okay. So that's the way it keeps on going on. Is it clear it up? Is this part clear?
Yes, sir.
Okay. The colored image. If you have a colored image, how does that work? Well, let me explain this to you. In case of colored image, it's always as you know, if you talk about RGB, red, green, and blue, this is the way we display colors in different formats. Okay. So RGB has R has 255 different color combination from 0 to 255. Green has from 0 to 255 different combinations, and blue has 0 to 255 different combinations. So If you multiply 255 multiply by 255 multiply by 255, these are the number of combinations that you have for within your color mixer. Okay, in any graphic software that you're talking referring to. So 0 stands for basically black and 255 stands for white. Remember that. Okay. We also refer to 5 as FF and we refer black as 00 in this in the back end. Okay. So 0 and 255, just remember that. That's the way it's done. So in between, you can have any different combinations. Okay. So if you look over here, how will we read this? So this produces the following data. So two zeros, which means 000 stands for black. 000. Okay, I just told you 0 stands for black. So 000 is black. 255 is white, and this is some cyan color, so green. This is RGB, and then you have is red is 25500. So there are two blacks. There are two blacks. Yes, there are two blacks. 1, 2. Then there are 4 green. There are 4 greens. Then there are 3 blacks again. 1, 2, 3 blacks again. Then there are 6 white. Okay. So this is the way you will be displaying them. Okay, one by one. Now, so that's the way your Runlength encoding basically works in this way. Right. Let me get back to this. So I've given you enough explanation. So I will share this with you as well. Okay, these part. Okay, this part I'll share this with you as well, so that I'll share in the group because there was less explanation, so I want to explain it more. Okay, so as far as sound is concerned, okay, remember that sound is represented through this way. Let me explain this more. For example, let me have some space for you to explain. Okay, I can explain this way. This is your sounds wave. This is one wave. Now over here, this is what we have. Is this one cycle complete? Yeah, this is one cycle complete. So over here we have these dots. These dots. I'm talking about a sound sample in one wavelength. So this, within the wavelength of a sound, we have these dots which are known as the sample rate. So from here till here, how many these samples do I have? Do I have 20 samples? Do I have 100 samples? The more samples that I have, the more clarity of the sound file will I have. पहली बात तो ये. Okay, so obviously the sample matters a lot, but obviously if you keep on increasing the samples, the size will increase as well. It's directly proportional, just like pixels you have. Okay, so and the bit depth basically means that what is the bit depth? The height of it. Okay, is the bit depth. So that's why we calculate. So in order to calculate the bit rate, we do is we sample rate. Okay, sample rate. How many samples do I have? Multiply bit depth into number of channels, which means stereo or mono. So let's say a CD file has a sample rate of 44 kilohertz. Okay, kilohertz. If you convert into hertz, this will be 441,000 hertz, as you know that. Okay, so I'm talking about kilohertz. A bit depth of 16 bits and 2 channel bits means obviously 2. So we will calculate it this way. Bit rate is this multiplied by the number of bits and multiply 2 channels. We get this much bits per second. And obviously, if you convert it into megabytes per second, you have 1.4 megabits per second, obviously, right? Okay. So this means 1.4 megabits are required to store every second of audio, right? Therefore, we can multiply the bit rate by the number of seconds to find the file size. So 3 minute 30 seconds audio file which is 210 seconds, would be you simply multiply your bits per second, multiply it by seconds, and you get this, and you can convert in megabits. Okay, right. So there are 8 bits in 1 byte, and we use bytes to measure storage. So the file size in bytes is divided by 8. So if you divide your this this bits by 8, you get is this, which is megabytes. So you have 37 megabyte. So it will take 37 megabyte for space. So this is some basic calculation that you should be aware of how it's done. You have to remember it. It's a simple method. You need to remember it. Okay. Okay. Right. This was just an example you can practice with. Right. So there are two kinds of compressions that we usually refer to. Okay. One is your lossy compression, and one is your lossless compression. Okay. Now, as far as lossy compression is concerned, it means, and the second one is lossless compression. Lossless compression reduces the file size without losing any lossless. We don't have any loss to the image, but it can only reduce the size about 50%. Okay. Lossy compression reduces the file size by reducing the bit rate, which means that some of the quality is lost. So in lossy, you will be compromising, with the quality to some extent. Okay. So in case of lossless, you do not compromise with any information while you're compressing, and obviously in lossy you do. This is the basic difference between both compressions that you have. Okay. So this is another example the same way that we have a file original has a bit rate of CD file has bit rate of 1.4 megabits per second. Okay. This is the speed at which data can be transferred. This is reduced to 128 kbps, which is this much kbps. Okay, so the original file size was this much. To calculate the change in the size, divide the original bit rate and multiply by the new bit rate. So what you have is you will simply multiply 37 MB with this and multiply it by 128 kbps. You will get is this. Okay, so you should know it, although it has never come such kind of conversion, but you should know it. In the paper, they have not asked you once, but obviously one should know it. So as far as video is concerned, obviously video, you have an idea. It depends on the frames per second. The more frames you have, the more better the video quality will be. This is why we have is ultra HD definition has these much pixels, for 8K, 4K has this much pixels maximum. Okay, then you have it extended, often you refer to as HD in projectors and all that. We call this HD, that's also HD. This is your SVGA, it's not HD, okay? It's super video graphic array, this much resolution. It's not now widely used. And this is the full screen size, but even this is not used now. This is an old phone screen size that you have. And now screens even have better resolution. Okay. So advantages and disadvantages of encoding data. Let's have a look at this. This is important. So obviously one purpose of encoding data is often to reduce the file size here. So obviously one of the most important thing is the reason why we're encoding data is we are reducing the file size. Okay. The reason why we're doing it, we are enabling real time of music so that online we can play them, okay, in real time. Okay. We want to reduce the size so that less time is taken for downloading, faster downloading of websites with images and music. If any background music is being played and used, we can it will be faster downloading for that. enabling more music and videos to be stored in CDs and all that. So, but obviously, if you're able to encode, and you will be able to compress more data into it. Okay. So it's not only encoding is not only referred to this. This is the reason why. Can you hear me better? All of you can hear me.
Yes.
Yeah, there was some interruption actually. Yeah. So this is not the only thing. You also have a difference between JPG, which is the most widely file format, and you also have is BMP. BMP, like I told about even last time, is Windows bitmap file format. Uh, Initially, it was developed and widely used. Now, it's also developed by Windows for within the operating system. All these that you see, the loading of the Windows and everything, is their bitmap images. But bitmap basically consume a lot of space. Okay, it really needs a lot of data compression. Okay, run length encoding needs to be applied on it. So if you apply a run length encoding on BMP, you will come up with a better format such as JPG. So encoding, you get encoding one file format into another file format. So obviously this reduces the file size to a lot of extent. JPG, this is why JPG tends to be one of the best file format, because JPG takes very less space, and you do not uh, see the change in the quality. Okay, so this is lossless compression when JPG is there. Okay. JPG, that's what is one of the most famous. You'll find in phones, in tablets, everywhere. You'll find JPG file format. This is one of the best. Okay. Uh, this is what they've explained over here, right? All over it. Okay. Now, one of the disadvantage of uh, in codecs will be that, okay, for images it's not a big problem, but otherwise if the required codecs may not be installed, like for example in case of a video, if you convert into different for file format, maybe your computer will not be able to play it if it doesn't have a necessary codec. They have to be installed. Okay, not all software is capable of opening different file types, right? And some hardware such as music and video players only play video file encoding in certain formats. So basically it's all about formats, that not all formats are played everywhere. There could be an issue, okay, in this particular case. So and if you're converting through lossy compression, you will be compromising with the quality. Okay. Text that has been encoded using SQL needs to be decoded using correct format when it is opened. If some international characters have been included using Unicode, then the file is opened as an ASCII code. Yeah, obviously, it's common sense. What this saying is that you did convert an ASCII code into Unicode, and if you are converting back from an ASCII code into Unicode in some other computer, and if that computer does not have Unicode, so obviously Unicode has lots more characters, and those characters are not in ASCII code, so obviously they will not be displayed. So maybe any random character will be displayed as A, any random character will be, which is not defined, will be displayed as Z, or whatever. Okay, that's the point. So since ASCII code has limited codes, Unicode has a lot of codes. So if you try to convert a Unicode into ASCII code, you will have problems and your characters will not be displayed the way they should have been displayed. Encryption, we'll talk about encryption now. Encryption basically, obviously, is to convert data in a form that cannot be intercepted, even if intercepted by someone, cannot be decrypted unless and until a public key is entered to decrypt it. Encryption has taken lots of forms since the advent of computers. Okay, so the reason why encryption has been so important is so that our information does not go into wrong hand. Obviously, we don't want our information to go into wrong hands. So if we start from the history of encryption, we will study very different ways. And one of the most initial method of encryption is the Caesar cipher. The reason why it's known as Caesar because it defines a set of rules to follow to encrypt message. Roman Emperor Julius Caesar created the Caesar cipher. Okay, so it's a very a simple way, by the way. As you can see, let me zoom in a bit more to explain you this. So what's happening in the Caesar cipher encryption method is, for example, obviously this is your original ABC that you have, and then you encrypt the data and you tell someone that I will be shifting my 3 characters. That's the way I will be encrypting my data. When I shift 3, this means A is D, B is E, C is F. Because I've shifted 3. I'm starting with D. You see, I'm starting with D. You can see over here. And D is G, H. And once I reach Z over here, I again start with A, B, and C. I will be completing all my alphabet, sorry. So if you have to basically encrypt hello, you will write H.
सर आपकी आवाज
आवाज नहीं आ रही? Okay, hold on. Hold on. Just 1 second. I'll just change the position. So is it better now? Hopefully you can hear me now properly.
ठीक है.
Yeah. Okay. अब देखो इसमें if I have hello, so hello, what do I have? See over here. In case of H is K, E is H, L is O, and O is R. So hello will be this. So if I write a sentence using this, no one else will be able to know what I've written. It's a way of encrypting information, a very good way. Okay, and you can just tell someone that I've shifted how much. Obviously, in order to decode this, will just take some time. But yes, it's an initial way, and it was a very good way to encrypt information. There is another very interesting method, maybe some of you are aware of, is the Enigma machine, which was basically invented by Germans in the World War II. And this was invented because they were obviously going through a war with the British, and they wanted to obviously encode information, and information is everything during war. So this was a very brilliant way. Okay, it was developed during the Hitler's regime, and obviously I will not be able to explain it this way right after this first lesson of ours. In the second lesson, this is like 25 minutes. I will not ask you to do any other work today, but please let this be a part of it. It's a 25 minutes video. I would like you to have a look at it, that how does the Enigma machine work. If we were in the lab today, I would have shown this video to you. It's the same thing. My class card, I will share the the video of Enigma, and please watch it. इसके बाद मैं आपको दिखाऊंगा. Let's go. See how does it work. It's a very brilliant thing, by the way. The British were able to make the replica of the Enigma to basically counter the Germans, but obviously it was not exactly the same thing still. Okay. Right. And then we have is about symmetric encryption. Okay. There are 2 kinds of encryption that you have. So in symmetric encryption, you encrypt using a secret key and decrypts using the same key. Okay. So In symmetric encryption, you have is one key that is used to decrypt and encrypt. In asymmetric encryption, you basically encrypt using repeated recipients publicly and decrypt using same algorithm using their matching private key as well. Okay, I'll just explain this in detail. Just one second. There's certificates. So basically, what happens in we'll discuss this later on. बाद में उसको discuss करेंगे in detail. So symmetric and asymmetric में फर्क क्या है? In symmetric encryption, we decrypt using just one key. Okay, and over here we have two keys through which we can basically decrypt the information. Obviously, one key was not safe, so we had to use two methods to basically do it. So we'll discuss this later on. आगे फिर आएगा इसकी discussion. मैं detail में discuss करूँगा. Okay. Now we have is the discussion that let me zoom in more to show you this. So when encrypting data, asymmetric encryption uses secure socket layers, SSL. Secure socket layers basically is a way, it's a protocol over the internet that makes sure that whatever information that is being transferred from one computer to the other computer, that information will not be decrypted in the middle. So this is what secure socket layers again are. Again, the discussion of secure socket layer is just an introduction over here. We will be discussing secure socket layers in networks in a lot more detail that what do they actually do. But I'm just telling you right now, these are just the layers that help you in protecting information over the internet, over any network, LAN, WAN, whatever you're talking about. Then you have transport layer security TLS, which is a new version of your secure socket layer. Okay. Secure socket layer, you will usually see a padlock, which is at this padlock that I'm referring to. Okay, you'll find it on various websites. You'll also find it on my website. It was not there on my website few months back. Secure socket layer is related to HTTPS, Hypertext Transfer Protocol secure. This is for secure. You also have domains that are simple hypertext transfer protocol, but they need to be secure as well. If they're not secure, this means the information that is being sent from your computer to and the server of that particular website, anyone can intercept in between. So now usually the servers demand all the websites to have HTTPS. Okay. Initially, my website was not that. So you have to make is socket layers. The script that you have to type in, you have to install on your server, and only then you will find your website. So if you come over here, you will see even I have now this. And if you click on it, it says the connection is secure. Like 1 month back, this was saying not secure. Okay. And in my both websites, if you visit the other website as well, that was the same case. So I had to do it on my own. Obviously, they were charging a lot more. The server companies charged a lot. So I did type the script myself, and you see even this is secure now. It's secure. So the disadvantage is that if this is not secure, there will be a big problem that your Google rating of your website will fall down to a lot of extent, because Google does not want to display information from websites which are not secure. Obviously, it's not a big problem. I'm not taking anyone's information from my website. And this is a problem when you have is a college registration form. You are asking for students' information, or shopping website, or banking website. These are different cases. But altogether, obviously, the World Wide Web made a rule that we have to have a means through which everyone has to follow it. So they did not distinguish, they just made a rule. Anyway, again, long discussion, but we'll talk about it afterwards. So disk encryption will encrypt each and every bit of data stored on the disk. So disk encryption is also there. This is a different encryption, single file. Again, these all topics, they should have not discussed over here, because we will be discussing this in more detail in the network chapter. Okay. HTTPS, like I just told you, it's Hypertext Transfer Protocol, and you have Hypertext Transfer Protocol. So it's one of the protocol that is used for information to be transferred over the internet. So HTTPS does is that if you open up any website, mrsign.com, for example, you will see images, the content of the web page, the contents of the web page, which basically includes images, videos, text, sounds, cascading style sheets, all these things. They are basically being transferred through a protocol which is known as your HTTPS. Remember that. So HTTPS basically works by using the two methods, use SSL, okay, or the TLS, which is the new form. So HTTPS will be using both of them. The advantage of this will be that the information between you and the computer with the user using this will not be intercepted. So, like I just told you, they're used by banks or other people who are online into e-commerce based websites. They will be using it. So you'll see the padlock. We just talked about it, right? So basically, what happens in your asymmetric encryption is the web browser then uses the. So I don't want to discuss it right now. Like I told you, we'll discuss it again. Leave it. So you have email. Email encryption also uses asymmetric encryption, which means obviously in email you have to enter is a public key and a private key. They're both ways. It's a safer method. Okay. How encryption protects the data? Obviously, encryption protects your data so that by using two different keys that so data cannot be decrypted. That's the way it basically happens. Checking accuracy of the data. Well, you have studied this before. You know what is validation and you know what's verification. Validation simply means to use different rules, set of rules to validate data. And verification means by using double entry and visual verification. So in validation, we have different checks. We do validation in Excel. We have done the validation in JavaScripting. We validated text box. So you have different validations such as range check, you have presence check. Okay, so there are different checks that you have. Maybe they have mentioned over here or not. Like in any form, okay, we can have a presence check, we can have a length check. Okay, in the address we can have a character check. In the city we can have is again presence check. So whatever. The point is presence check, range check, enter value between this and this. Okay. Then you have is type check, which means we need to see that if a particular character is present or not. For example, is at the rate present in an email address, it's a character, it's a type check. Okay. We have a length check to see how many characters do I have. We'll call it length. Mostly in password, you use a length check. Format check, we need to check the format. Okay. Usually in date, we have the format. Lookup check. Lookup will be used to check whether it's male or female, M or R. Okay, most of encoding. Okay, lookup. So we can use lookup check as well to check from the list. Consistency check to basically see that consistently data is being entered, M or F is being entered, MRS or MIS is being entered, so on and so. Check digit. I'll just discuss check digit afterwards. So what I mean to say is that your validation is a way through which computers or programs help you to validate information. Verification, on the other hand, is through double entry system. So humans, you do validation. Both verification and validation are two ways to maintain data integrity. How do you maintain data integrity? Data integrity means data is supposed to be in the form the way it was supposed to be saved in. Is it being saved in that particular form? Okay, so that's data integrity. So let me scroll down again. Let's talk about बेटा ये ना मैं 1 मिनट रह गया दरमियान में डिस्कनेक्ट होंगे हम तो आई एंड आप ज्वाइन दोबारा करो उससे ना टाइम फिर हमारा सेव हो जाएगा ना मतलब I want to discuss this in a consistency. It's something important. Okay, मैं disconnect कर रहा हूँ. Please join again.